just have 3. There's 34. We need to make 34 pounds. So we give 3 to 1 to 50. That makes it. But if we give 1 to here, it's even, and it's supposed to be twice as much.
Okay, stop.
So, like, let's have they each have 1. So, since one of them has, was it Bruno? He gets twice as much, and
Right? So this is
and if let's, but he's twice as much again, but he's 1 more than twice as much. So that's where that one goes.
Twice as much as 11 plus 1.
course it matches. The purpose of education is to prepare children for their adulthood. 150 years ago, that's how you did it. Patience, obedience, tolerance for boredom, subservience of the individual. Well, I come from Silicon Valley, and that's a workplace there. Difference. Everybody's talking. They're brainstorming. She's got 3 screens open. He's on his phone. Is that okay? He's crying. I suppose that happens. The workforce today requires a lot of communication, a lot of creativity, because machines can do everything else. I imagine the machines are making cigars now. Don't know. And this is our kindergarten. Look at the match. So what do you see? Independence, communication. Yeah, manipulatives, we call that manipulatives, things they can touch. Dominoes, blocks, teddy bears. It's playful, yeah. What do you not see? Yeah. You do not see pencils. They hardly use pencils in first grade, especially the first beginning part. To build a sense of 10 or 20, everybody by 5 years old, they can count to 20, but can I show them, okay, I have 12 blocks, put 8 behind my back, show you 4, how many are back there? No. They don't really have that number sense yet. That takes a long time. Squiggle plus squiggle, I can do that very quickly, but actual number sense, no. But memorization is not enough in today's world. Oh, did you get a handout? On the last page are some codes. They're links to articles that you might find interesting. Okay? The first one is PISA test, Scientific American, and here are the results. This is an international test called PISA. In every country, the memorizers turned out to be the lowest achievers. This was especially true for the United States. We are totally still memorization based. And countries with high numbers of memorizers, the US had a high number, also had the highest proportion of teens doing poorly on the math assessment. Memorization is not good enough anymore. This math assessment is not computation. It's not a test you could give a computer, a calculator. It is word problems and problem solving, and we don't do well. So I want you to do some math again. You can use a pencil. You don't have to. Go ahead and figure it out. Well, maybe if you're getting an answer, could you tell the person next to you how you figured it out? Oh, brilliant. Wow. Excellent. Wow. This is an amazing parent body. I'm impressed. So I am in a similar school to yours, about the same size, but it's only K through 8. Sometimes students join us at older grades, and this is a 4th grade class. We had a a visitor who wanted to join for the following year, and we give them a little sample test just to see what kind of work they do. And he did that problem, and he's obviously had some good instruction. He's coming into 4th grade. Someone's taught him well. Look, he knows how to borrow and carry and put the 10 over here. But the algorithm is especially accident prone. It's highly accident prone. They only teach it because it always works. They only used to teach it because it saves paper, and paper was expensive. It's accident prone. And he had no idea that he had this mistake. So gave the same question to my own 3rd graders going into 4th. Oh, machines are fast and accurate. Getting more so, right? They're starting to think. But stupid. Humans are slow, inaccurate. You never make a mistake calculating, right? Slow, inaccurate, and brilliant. It's the only thing that's going to save us from these machines. Here's one of my students. What did he do? Talk to a person nearby to figure out what this child did. You can see he added the first 2. That was easy. But where do you get 100? Why? Who ever mentioned anything about 100? My problem says 99. What did he do? He rounded it up. Okay. All right. Well. And then he rounded up the other one to 200. And then he got 2. Because 302 minus 300 is 2. Now this has all been subtraction, so then he has to subtract 3, right? And he added 3? It doesn't make any sense, right? Why did he add 3? And this is what I will ask the children too. You're kidding, you kind of added 3. You were supposed to be doing subtraction. It's what he added to make it round up. You haven't convinced me. Someone's talking. They are negative. He subtracted 3 more. You still haven't convinced me. Yeah. Okay. I'm kind of getting it. He set aside a 1 and he set aside a 2, and that's 3. He kept us 3 and 2. Okay. These are 2nd graders. Okay, 3rd graders. I'm not going to confuse them with negative numbers. You need to convince me as if you were moving the blocks, as if you were making sense of this.
They are probably used to working with the number groups, 10 each, so 100 and 200 they can work better.
Of course, absolutely.
To make it 100 and 200, they have taken blocks, more blocks. So as many blocks they have taken on this side, they are
Too many? There's the words that a child will understand. This teacher lady took away 100, and she was supposed to take away 99. She took away 1 too many. And then she took away 2 too many. She just made up some numbers and said, oh, well, give me an extra block and give me an extra 2 blocks. I'll give them back to you. I promise I'll give them back. And she took away too many. She has to give them back because she took away too many. That's the meaning behind this. And it's hard for us adults to see past the abstraction and past the algebra and actually make sense of things. But the children, because they've been learning with blocks and blocks and blocks, they can do it. He knew exactly why he did that. He said, because I took away too many. I got to give them back. Here's a brilliant one, and I heard one of the parents say this too. What did they do? What did this child do? This one. You're brave.
I chose the closer number. That's how I did it.
You did. You sound. You. What did you do?
I chose the closest numbers, like 101 and
Okay.
201 and 198.
You moved them around. You can do that. If I'm in line at the lunch counter, I can cut in front. Is that okay? The 99. If the 99 cut in front of the 200, why isn't it plus 99? So this is what we do with the children. We question their thinking. They know what they're thinking. We force them to put it into words. Humans are much more skilled at verbal skills than at math skills. So putting it into words, they will tell me, yes, you can move the 99 if you take his nose with him, if you take the minus sign with him. He cuts in front of 201. We've got, that's easy to do. 100, 101, that's 2. That one's 3. The answer is 5. Okay. So we're looking for what? Mental math, efficiency, understanding, verbalization, and all of that is based on concrete pictorial abstract. And you'll notice that I'm not telling, I'm asking. The teacher will be asking all the time, what do you think, what do you notice, what do you observe, what's happening? We call it the 4 C's. Creativity, collaboration, critical thinking, and communication. We call it the 4 C's. Remember that classroom from 1900 was not fostering this. You choose the job. Customer service. I don't know what that is. Robotics. The auto mechanic. I can remember when an auto mechanic actually figured stuff out. Our mechanic now puts a sensor in the car and goes back in his office and turns on the computer. That's an auto mechanic. It's all about collaboration, creativity, critical thinking, communication, technology. And where do you learn that? Where's the best place? I have a bias. Where's the best place to learn that? In the math classroom. I am saying that the math classroom can be one of the most creative places, full of critical thinking, questioning, independent creativity. So you're supposed to be like excited. You can smile. There. Okay. So remember that picture of our kindergarten? What are they learning? They're learning to observe. And from what they see, they try to build meaning. The human brain loves patterns. They will build meaning. I don't have to tell them. Looking for patterns is what we do. They're learning to listen to others because you saw it differently than I saw it, differently than he saw it. Figure things out. That's critical thinking. And think independently. So we are going from a precept that intelligence, math understanding, conceptual development lies within the child and just has to be full. We just have to facilitate it coming to the top. It's not that the child is a blank slate. I open the brain and pour in the knowledge and close it back again. It's a completely new way of looking at teaching. So that and that and that is not going to give us those skills. Concrete, pictorial, abstract means we start with the blocks. We don't usually actually start with apples. That's your job. You can give them apples. So she started with 5 blocks on 5 fingers. We have a base 10 because we have 10 fingers, a sub base of 5. The blocks come off the fingers onto the table. That's the first abstraction. We can't make them stop counting with fingers if we don't substitute something else. They're going to use fingers if there's nothing else that they've learned. So the blocks come off the fingers onto the table. From the table, they go to a 5 frame. They count. You count that once and you know that's a 5 frame. A 4-year-old counts it 20 times, 50 times, 100 times, depending on the child, before they're immediately looking at it and saying, well, that's 5, and counting on from that. They're children. But they get there. We put it on a 10 frame. We switch the blocks for dots that you can't move. We put them in a different configuration, and it's still 5. We have to do that while they're still blocks, moving them around, and nothing has magically disappeared. It's called conservation of quantity. To an empty 10 frame. This means they're almost there. There's an empty 10 frame on their desk in first grade, and they glance at it and they can see the 5. They can see the top row full, or they can see 3 and 2, or they can see 9. We call that a hungry 10 frame, the one missing. They see ghost dots in different configurations. The Singaporean Ministry of Education says that visualization is the most important skill that young children can learn. And then they finally learn the 5. And by the time they write that down, they're like, of course, I know what 5 means. So we build towers, we make patterns, we put beads on bracelets. It takes a long time to take a child and let them develop that concept of 5 on their own, and 6 and 7 visually, conceptually, so that I can say the number of the day is 7. How many are in my other hand? And they can say 4. That's number sense. Squiggle, 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 squiggle equals squiggle. That is not. Right? Build towers, the whole little city. They use the blocks to understand word problems at first, and then they forget about the blocks and just use the bars. They can do area and perimeter in 2nd grade because it makes sense. That's a rectangle. That's a rectangle. Little spaghetti pieces go around the outside for the perimeter. Fifth grade. Can you do that in your head? Or do you need algebra? I can't do this in my head. I can do a lot of Singapore problems in my head, but 5th grade, I need a model. So go ahead and use a pencil. So to interrupt you, if you're thinking, sorry, what we see is that the first couple years of school, kindergarten, 1st grade, 2nd grade, it feels like it's going really slowly. By 4th and 5th grade, they have this huge pyramid, this foundation of mental math, of number sense, of base 10, of computation in their heads. And suddenly it starts going really fast. So I was a middle school teacher before I was a math coach. And by the time they got to middle school, they were so far ahead of kids in other schools in terms of understanding. So how did our children do this? Blocks. Mark has 3 and Ryan has 7. We don't know, those are boxes and we don't know how many stickers are in the box. And of course, one boy in the class is going to say, who cares? It's just stickers. So you go deaf. Ethan has twice as many as Ryan, so 7 turns into 15. Why is it 192 divided by 24? Yeah. I often ask the children, why do we spend the time to build a model, to draw a model? And they're supposed to answer so we can count. You count that up, you get 24. Three sevens and a 3, 24. So 192 stickers in 24 boxes, probably 8 20s and 8 4s, yes. 8 in each box. So now all I have to do is say, well, Mark has 3 and Ethan has more than 3. How many more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 88 is the answer. So are they ready for algebra when they get to 8th grade? They are. They are. I was a middle school teacher. I was the one teaching the algebra. I saw unbelievable progress in our 8th graders. When I started at the school I'm at now, 25 years ago, hardly any of them could actually finish the algebra course in 8th grade, a high school algebra course. Today, 80% can finish the algebra course with good understanding, because they know word problems, they know fractions, they know computation, they know that the distributive law is just 7 times 14 in letters instead of numbers. That binomial multiplication is just 2-digit multiplication with letters instead of numbers. At the beginning, this takes time. Please be patient. Please, if your child's in 1st grade, be nice to those teachers, because you're going to be tempted to complain. I've been doing this 20 years, I know. The Singapore math, I've been teaching longer. I'm a parent. I know how precious these people are, and I know nothing is more precious than their future. It will come. It will come. Instead, watch them think. Ask them questions about, suppose I had 10 and 2, and then I gave you one. I had 10 and you had 2, and I give you one. What, do we have the same number, and how many do I have and how many do you have? And they'll know. You don't need to write it out with a pencil. So what does it look like in 1st grade? How many ways can you add 8 plus 7? Not what is 8 plus 7. And I think it's cultural, but in the teacher groups and in the parent group, when people get the right answer here, they're just like, I got it. In the US, when I'm in classrooms or teacher groups and they get the right answer, they're like, I'm not sure this is right, but maybe, and it's completely different. Did I at least approach it right? I'm not very good at math. So 8 plus 7, here's what some children do. They move 2. We love 10s. We have a base 10 system. You have to love 10s. We write 8 plus 7. There's 2 numbers living inside the 7. There's a baby 2 and a baby 5 inside the 7. And that's what this it's called a number bond. Again, Singapore did not come up with this. A lot of their bar models and number bonds, can I say this? Came from Russia in the Soviet time. Okay, I said it. Okay. And they know that when I moved the 2 to the 8, I got 10, leaving 5 behind, so 15. This is all mental. I don't have a pencil yet. Another child might move 3. It's not as efficient, but that's fine. Eight is got 5 and 3 inside of it, so 10, 5 again. We I often would reward a class for coming up with more than 3 ways to do a problem. They get a marble in a little jar, and that gives them a little extra recess time or something. So even the fastest thinkers are trying to get fancy and come up with some more methods. One of them said, I'm going to move the 2 and the 3. I got 3 5s. Because the 5s are so important. We have a base 10 system with a sub-base of 5. Oh, there's more ways. We could use doubles. And I'm not sure what it is about the human brain. First graders learn doubles faster than non-doubles. I've not seen research on that, but it is interestingly true. So I know 7 and 7 is 14, and that's 1 more because of the 8, so 15. You'll hear that. Or the magical invisible egg, the one you don't see. It's 1 less than 8 plus 8, if I happen to know that fast. Or 5 less than 10 plus 10. I've had children do that. I had one girl who did all of her numbers. She would round it up to the next 10, even if it was 13 or something, round it up to the next 10, and then take away that many. And I just watched to see what's going to happen. She dropped it in about 3 weeks because she said, you know, I think there's faster ways to do it. Yeah. But it was there. It was building number sense all that time. Why spend so much time? Why not just say 15? Remember that. That's what happened to us. I don't know how old you are, but did you get a little slap on the shoulder? Okay, that helped us remember. It did. Emotional connections to facts help you remember. It's just not very good emotions. So if I know 10, 5, that 8 plus 7 is 10 plus 5, then I know that 18 plus 7 is 25. I know that 98 plus 7 is 105. All of this becomes mental math, no fingers anymore. And 8/10 plus 7/10, 1 whole, 10/10. You have to build that a few times in 4th grade, believe me. 10/10, 1 whole, and 5/10. Not 1500ths. Believe me, you see that. 0.15, believe me. Otherwise, if there's no number sense, you're going to get the answer 0.15. 1 and 8/10 and 1 and 7/10 is 2 whole, and 15/10, which is 10/10 and 5/10. So 2 wholes, 3 wholes, and 5/10. My point there is that in the long run, all this time invested in 1st, 2nd grade pays off beautifully. Pays off. And if you're making them memorize things, maybe you're short-circuiting that learning a little bit. We use egg cartons. They're over there. We use the workbooks. This is Sam. He's in the workbook that my school uses. And what is Sam thinking? We turn it into a word problem. Sam is adding white rabbits and brown rabbits. But actually, if you're adults, you know that rabbits multiply. They don't add. Anyway, my attempt at humor. The children have to say what he's thinking. He's thinking of the number, that's covered up at the moment. He's thinking of the number bond of slide a 1 to the 9. 9 is a hungry 10. You're left with 4, so 10 to 4. That's what Sam is thinking. Okay. This is a kindergartner. I asked her a simple question. You have 4 blocks, and I have 4 blocks. And the teacher gives you 2 more. There's going to be a storm of words here, so listen carefully. I can't slow it down. I don't have that technology, but here it goes.
Put these 2 together, and then you put these 2 together would be 2, and then if you put these two together, it would be 4, and then if you put these two and then these two, it would be 2, 4, and then if you put these, it would be 8, and then I would have one more, so then I would take 5 of mine, like that, and then I would get 6, and then you would have 4, and then together it would be, and then I just go 1, then I just go 7, 8, 9, 7, 7, 8, 9, 10.
Okay. Was that the question I asked? What was my involvement in that? I was silent because I was amazed. But when you listen to it, you have to notice how much learning by talking is happening. How much she's learning by talking. She's got the 4 and the 4, 2 and 2 at 4, and 4 and 4 is 8, and then she separated that into 2 groups of 5, and then she had her extra one for 6, and then she was going to count on 1, 2, 3, 4, but she stopped herself and she said, I have 6, so 7, 8, that's huge. When a child is not counting all, but counting starting at 6, 7, 8, 9, I wasn't sure she'd counted that right, so 7, 8, 9, 10. She's building math understanding rapidly during that flood of words, so I would never stop her. Even if she got it wrong, I would wait until the very end and say, that was amazing strategy. I think we need to count maybe at that one step, count the over again, but at this point, it's all about building that number sense. Would she be learning more with that worksheet? No. So we give them hard problems. I don't want you to think that all they do is play games with blocks. Children would learn math. This has been proven over and over. They would learn math on their own. Street children in Brazil learn math without any education because they're selling things on the street. You would learn math, but it takes a long time, so we nudge them a little bit. This one, Yanni made 100 paper flowers. She first made 2 red, then 3 blue, then 5 green, and she repeated it until she made 100. How many blue flowers were all together, and what's the color of the 87th flower? Now, adults are always impressed with this. Even though I tell them sometimes I have to read it to the first graders if their reading isn't so good yet. You know why they can do it? They can all do this. Different speeds. We have children we call racers. Do what you just did. Blue. And we have builders, children we call builders. We love them all. They're all going to be, they're all. My son walked at 10 months and my daughter walked at 14 months, and you can't tell the difference today, believe me. Our builders get through high school math excellently. But what are the builders going to do? They're going to build it. Now what? Half of the class gets it after building 1 row. The rest of the class gets it after building 2 rows. No, there's always somebody who insists on building all 10 rows. There was one girl I had once who insisted on drawing 100 flowers in 3 different colors, and it was a 2-day project. And, I almost put my foot down there. Okay. Now it's easy. Often I will give them a 100 frame, 10 by 10 frame, to start this with. Well, look, teacher, the 7th one is green, and the 10/7 one, and the 2/10/7, and 3/10/7, it's always going to be green. And how many blue? Well, 3 in the first row and 3 in the second row, 10 rows of 3. 10 rows of 3, that's like 3 rows of 10, 30. So this is something that you could not give a classroom of 150 years ago. Remember that black and white classroom there? This is today's teaching. This is today's thinking. Oh, here's the thing we do in second grade. You want to turn your class into a factory, you give them dump out a huge box of straws and tell them to count them by tens, and they set up little assembly lines. You count the 10, I will wrap them, and you put them in boxes of 100, and it goes crazy busy for 15 minutes. And when they're done, they have 1,000 straws or 2,000 straws, and there's some understanding of what 1,000 is. 4,000. I know you know how to do this. Do you know 2 ways to do it? You are shopping at the Mall of India, and you want to buy a 4,000 rupee purse, and it's on sale for 359 less. You can do this, right? Maybe not. Maybe Siri? Okay. Here's how I learned it. You cross out the 4. You can all nod. It can look painful. Write a 3, put a 1 in the air, cross that out and put a 9 and a 1 in the air, cross that out, put a 9, wait a minute, and a 1 in the air, and then that's enough. Okay, now you can subtract. Did you know what was going on here when you were 10 years old? 9 years old? No. Was it 8 or 9 years old? Did you know what's happening here? Oh, what's happening is that there are 4 of the thousands, and each 1,000 is 10 100s, and yet we cannot subtract in the hundreds place with that 0 there, so we are going to go to the thousands place and knock on the door and say, can we have 1, please? And they will give us 10 hundreds, and then we've got 10 hundreds, but we're going to have to repeat that so that this is how the children explain the algorithm when we finally get to it. Okay. Here's what our third graders, before they master the algorithm, they have other ways to do it that they've learned from the blocks. Think of it as 2 people and make them each 3 years younger. They know this from their siblings, that my brother and I will always be 3 years apart, even as we get older. One of the boys told me one time, unless he dies. And I couldn't believe that, but I pretended to be deaf again. Think of it as 2 people, make each of them 3 years younger. They are now 4,000 years old? It's rather biblical. Now they are 3,999 minus 356, which is easier. What do you think of that? Pretty cool. This comes from the children. I do not teach this. This comes from them. Use number bonds, because they've been using blocks and number bonds for 3 years now. 359 is 350, 7, 2. So take away the 2. This is probably how you would do it, right? If you had to be accurate and you didn't have a pencil or a phone, take away 2. I get to 4,000. Take away the 2, I get to 4,000. Okay, 357 to go, okay. Take away 350, I get to 3,650. And I've got 7 more to go. Take away 7 from 3,650, I can do that. All right. So that's how a lot of us, I think, would do it. Oh, a lot of us would just round it off, make an estimate. One child said count up. Start at the 359. 41 makes 400. 600 will get me to 1,000. I've got a ways to go. 3,000 will get me to 4,000. 2 more, to 4,002. 3,641, 3,643. That's what I added on. This is supposed to be impressive for third graders. It's our goal is that they are flexible thinkers, that Any one of them could come up with 3 different ways to do this. That's flexibility, that's creativity. And it's more permanent. There you see the place value columns and the blocks. Math makes sense. Okay. Promise not to look, okay? Look at your knees. Raise your hand if you ever felt anxiety in math class. Come on. Nobody? Of course. Well, I'm not looking. Of course, most of us did. Let's avoid that. Let's make it something that is fun. Your children's math class. I'm doing some math right now. Yeah. Your children's math class might start with a warm-up where I ask them a question, how are these 2 things different? How are they the same? First grade. Number lines are really difficult. So what do? We give them a piece of paper, give them blocks. All of a sudden it's easy. 0, 10, 20. 20, 30, 40, 60. 4th grade, 3.7, 5.1. The child is going to go, well, 1 whole makes 4.7. That'll get me to 5, 3/10, and 1 more tenth to 5, and 1/10. That's 14, so halfway there is 7/10. So 4 and 7/10. It's a miracle to watch. I'm the math coach from kindergarten to 8th grade, and I just never get over it. How this mental acuity, mental flexibility, they're little mental gymnasts. They might, after the warm-up, they might play a math game. This is a 1st grade one where there's, early in 1st grade, where there's a bag where I hide some blocks and a plastic one where the other blocks are, and a 12 and 12 on a 10 frame. And they have to tell me how many are in the bag that they cannot see. And then we switch. We might do independent work. They do have pencils. But they might have 4 problems, and we call it a day. They're that hard. 94 minus 57, do it in 2 different ways. And so here's work that we got from them. 2, 3, 4, 5, 6. 90, 9 rods, 4 ones, slide a 10 over here and it changes to 10 ones. This is 2nd grade, or end of 1st. Maybe this was end of 1st. Cross out the 57, and then count up what's left is 37. It's not very efficient. It's not going to last. This lasts. This is a picture of the blocks. This is the pictorial step. The next step is the algorithm. Can you see the algorithm in here? Make that 80, make that 90 into an 80. Make that 4 into 14. That's the next step. It's going to make sense. When we get to the algorithm, they're like, well, of course. This child used number bonds. 94 is 80, 14. They have to be able to slide a 10. So we'll ask them, as they're leaving the classroom, to recess one at a time, 62, and the child says 50, 12. 91, 80, 11. We have to build that ability to slide 10s back and forth. It's useful in division 2. So now that they've done that, they know that 80 minus 50 is, well, they did that one wrong. 80 minus 50 is 30. 14 minus 7 is 7, so 57. 37. This is wrong. Well, that brings us to a good question. What if the child has it wrong and the teacher takes a picture of it, I still say, that's a great strategy. I want you to check the blocks and see if the answer is 57, just to be sure. And they say, no, shoot, the answer is 37. And they go back and they find their mistake. And they say, wow, I had not only a good strategy, but I corrected my own mistake. Anxiety free. Sam and Marcia have 25 blocks. And we tell these stories about Sam and Marcia, that they're siblings, and there's some questionable parenting going on here because Marcia always gets more than Sam. And second grade, they can do this. There it is. And some of the students will start saying, I set aside, and your teachers said this yesterday, I set aside that one, because there's one here, and that leaves me 24, and I know Marcia has twice as much as Sam, so that's 3 groups. You can't tell me a second grader knows that's 3 groups without seeing it. And the problems get harder. If they're doing seat work for 20 minutes, the third problem can be pretty tough. Second grade. Oh yeah, I mean, I'm going to do it as an adult. I'm going to add them together and divide into and so on. Here's a second grader. Together they have 160. Three times as much means four boxes of dollars. So I divide by 4, 40 for Eric. Eric had 110. Take away what to leave him with 40? The answer is 70. So it is not procedural learning. When I taught at another different school before this one, the children would say to me, hello, teacher, nobody ever taught me that one. I don't hear that anymore. They all just take up their pencil and go, wow, let me think about that. That's what you want. Things so that I don't have to teach. I can just listen. Do you want to hear some problem solving again? This will be our next to last video. Kitaki, what is the time? When did we start? I completely forgot. You did too. You're not supposed to forget. Okay, I'm on schedule. You got it? At the beginning of the hour, you guys were yelling out answers. Do you have it? Okay, let's see.
So Cassie has 14 more than Keith. So they both have this 4. And
Keith has 4.
Keith has 4, and Cassie has 4 more than 14, which is 18. So Keith has 18. Keith has 18, and Cassia has 18, and Keith has 4. And Cassia gives half of them to Keith, and half of that is 9. So it gives the 9 to Keith, and now Keith has 13, and Cassia now only has 9. So there's 4 more. Keith has 4 more now.
Second grade. You can't tell me that a second grader without blocks could do that problem. I really don't think so. I don't think in my last school that fifth graders could do that problem. So the blocks are not watering down the curriculum. The blocks are actually adding depth and understanding. This is the last slide and last video. This is a third grader. And, I just go from classroom to classroom, so I don't know them as well as their teachers do. And nobody warned me about this quiet girl in the third row being such an observant, brilliant thinker until I heard her say this, and I said, you have to say that again because I'm going to get it on the video. She had this pattern, and she saw that there were alternating rows of 3 and 2 and 3 and 2 and 3 and 5 and 4 and 5 and so on. So that's how she solved her pattern series.
5 times 5 equals 25, and then 5 minus 1 is 4, and 4 times 4 is 16, and 25 plus 16 is 41. So that's the first pattern. And if it's 3 circles on the side, it would be 3 times 3, and then plus 2 times 2, because 2 is 1 less than 3. For 2 circles on the side, it would be 2 times 2, and then plus 1 circle.
Wow. Isn't that something? Third grade. She's seeing that pattern. And what I like about this is I don't have to teach. I don't have to explain everything over again. When I'm in the classroom, I don't even hear my name. In the old days, the children get stuck on a problem and all they do is, Ms. J, Ms. J, Ms. J, I need help, I need help, I need help. They don't say that anymore. They're like, oh, you won't help me anyway. You'll just say, have you asked the blocks? That's what I say. And so it's a wonderful way to try to teach children math. Math is fun, math is thinking. Humans like to think. I think you felt it yourself every time a new problem came up. Maybe I didn't give you enough time sometimes, but don't you just kind of like, oh, I think I can do that? And then when you do get it, there's an endorphin release. We like math. Take away the time tests, take away the stress, take away the memorization. Math is fun. Math is beautiful. What can parents do? Welcome mistakes. So they are, oh, I know. Here's a common one. You will see this, I promise. Yeah, I got it. I did it backwards. Okay. 51 minus 23. Well, I know I can't take 3 away from 1, so I'll do it the other way around, and it's 2. And 2 take away from 5 is 3. Okay. Teachers, are there any teachers back here? Have you seen that? Yeah. They'll all do it at least once. Yes?
My daughter does
Does it all the time. So what do? Well, this is not 1959, so it doesn't work. That's what I got. My 5th grade teacher would pull us on the ear. Wow, can you show me that with the blocks? And they got down 5 10s and a 1, and they take away 20, and they want to take away 3, and they go, wait a minute, I can't take away 3. There's only 1 there. I'm going to take away that 1, and then I'm going to cover up 2 on the last 10 here. Oh, I can't take 3 away from 1. I have to break up one of the 10s. They'll do it themselves. No teaching, no explaining. Tell them to ask the blocks. Tell them to explain it to you how they do it, or to draw the blocks if you don't have them. the thing about mistakes is that we all make them, and it's part of learning. If I were to avoid that mistake, well, maybe it'll just come back later. Or maybe I'll make it when I'm in 8th grade, and it'll be with letters instead of numbers. Answer questions with questions. Teacher, I can't take 3 away from 1. What shall I do? You're right. Let's look at the blocks and let's figure this out. I'm not sure either. What could we do? We have 5 10s and a 1, and we can't take away 3. We call them the math whisperers. Have you asked the blocks? And they can. You see, math is not like alphabet. An alphabet is made up. It's arbitrary. Greek, your alphabet is different. Arabic alphabet is different. That's a human construct, but math is not a human construct. Math is 51 blocks. 51 blocks is can't do it. And that's universal. That's what 51 is. So we don't have to teach it. It is all around us. Answer questions with questions. I don't know. Let's figure it out. Encourage building, drawing, telling stories, doing things in different ways. Take an egg carton and put beans in each cup. Put 1 in the first cup, 2 in the second, 3, and so on until you get to 12. Here's our 12, like ours. I wish it was 10. The 1 in the 1 cup goes for a sleepover, and the cup labeled 4. How many are in there now? Okay, half of those, or some of those, move into the 3 cup. What happened there? Tell stories, make it fun. Take your time. We want practice, not drill. We really avoid drill because drill kills the mental math. If I do too many worksheet pages, I lose my mental math skills. I do practice, which is explain it with mental math, show it 1 or 2 ways with a pencil to keep those creative problem-solving skills alive. Encourage different ways to solve a problem. Is that a life skill? Corinne always talks about, she's my partner, the mother-in-law problem. Okay, there are different solutions, you know. Fight back, don't fight back. Be nice, don't be nice. Move to Kazakhstan. You know, there's different solutions. You just have to evaluate them and certainly don't get stuck on just one. Wait until you're, okay. Take a deep breath. Raise your hand that you will do this. Wait until your child understands a concept before teaching him or her a computational shortcut. Yes, we can cross out the 6 and put a 5 in the air and move a 1 over here and subtract, and they will forget that. Maybe not tomorrow. Maybe Wednesday. It'll be gone. Okay. Unless you have a child with a remarkable memorization skill, and there are. About 20% of our children could learn math that way. And you know what? The highest scoring students on tests, they have done studies on this, they're not using algorithms. They figured out what the algorithm means and they use mental math. Okay. So we would prefer them maintaining those mental math skills. You can show them. You can show them. You know what? When I was little, you know how you just moved a 10 over to the ones place? We actually wrote that down. There were 6 10s, now there's 5 10s. And over here, you used to have 4, and now you have 14. They'll go, okay, sure. But to teach it without the understanding, you might as well be conjugating Latin verbs. So that is my spiel, and I've been giving that same message to your teachers. It is because my business partner is from Singapore. It is authentic. She and I have been in. We spent 2 weeks in Singapore visiting classrooms. This is what they really do, and they're doing more of it. They're moving the algorithms back even more. They're saying, teach less, learn more. They're saying, withhold the algorithm. They're saying problem solving first, and they're still scoring really, really high. We also got to visit Finland, Corinne and I, and on an educator's tour. Guess what? They're in the top 5 nationally. First 5 years of school, no tests, no homework, no grades. And they're in the top 5. There's so many models out there that we can look at, that we don't have to fall back on what worked a generation ago or 2 generations ago. In today's world, it's just, something interesting about our teachers today that is different from our students today? They were born in different millenniums. You were born in one millennium, they were born in another. So we have to acknowledge that. We have to go with what is going to be the future of communication, creativity, and thinking skills. So I thank you very much. I do put my email here in case you have any questions, and I'm going to be here for a little while too if you have questions. Thank you very much for coming. Yes.
I was taught this way. I would have never had
Everybody says
fear
that.
of math, which I still do carry, and that's one of the reasons why I wanted to come for this session to unlearn, actually, as somebody said very rightly, because that's the challenge my daughter and I face. Because I'll do the whole cross it out and do it this way because that's faster, and that's the only way I know. But the only way I know is not really the correct way or the right way to teach it. I mean, maybe correct, but not the most functional. What I now wanted to ask you really was, so now she's in grade 5. And I think a lot of the building blocks that she could have possibly learned between 1 to 4, she may have missed. So how do I ensure that going forward, at least her and I don't get into this loghan, and I kind of help her build those tools which she may have missed between 1 to 4? Is there a way that I can do that?
Well, you could go back and work with blocks. This is a hard one. When we adopted Singapore Math 19 years ago, I was the 5th, 6th grade teacher. And I went back 1 year, the 5th graders were doing 4th grade books and the 6th graders were doing the 5th grade book. And I tried to do a little bit of the blocks just for a few addition, subtraction, multiplication ideas. And I realized it's too late. They have established that mechanical approach. So I concentrated on fractions all through 5th and 6th grade, where they were still pretty raw on fractions. That was kind of a new skill. We draw fractions. So 5/5 is 5 blocks. 3/5 is 3 blocks with 2 boxes empty, just almost like a 10 frame, but 5 frame. And we draw fractions the whole year in 5th grade. So that's the biggest gift you could give her right now, really, because algebra, the make or break skill for algebra is not plus, minus, times, divide. It is fractions. And trigonometry is a whole year of fractions. So that's my recommendation. You look at her book and see how they're drawing the fractions, these long bars, and do that. Okay. There was another question. All right. Well, I'm here if you have questions, and I'll take the mic off. And thank you so much for coming. Thank you. Thanks.